Welcome. In this video, we are going to talk about solving equations that deal with absolute value. The first thing we need to know in order to solve equations with absolute value is that we need to understand what absolute value means. An absolute value means a distance, specifically the distance from 0. So when we talk about a distance, we always measure distance with a positive number. So absolute value just means the positive distance from 0. So for example, if we have absolute value, and again, absolute value is represented by these vertical bars, absolute value of -3 is 3 units from 0, as well as the absolute value of +3, that is also 3 units from 0. So if we are dealing with an algebraic expression, we'll call that capital X. So if we have some algebra here in between the bars, some expression, as long as it's equal to A being greater than 0 means that absolute value expression must be equal to a positive number. Greater than 0 means that this A value is positive. So as long as we have an absolute value expression equal to a positive number, then we can drop the bars, and what we know is that what is inside the bars, that expression X, is either equal to positive A or it's equal to negative A. So we could have +3 or -3 inside those bars, and my output, my absolute value, would be equal to 3. So let's look at two examples. This first example we have here, absolute value of X is equal to +3/2. This means that X equals 3/2 or X equals -3/2 by definition. So we could just say X equals 3/2, -3/2. That would be my solution. There are two numbers that I could plug into this absolute value equation that would give me a true output. The absolute value of 3/2 is 3/2, and the absolute value of -3/2 is +3/2. All right, for our next example, let's solve this absolute value equation for X. We have the absolute value of X equals -2. And most of you are probably saying, well, that means that X is equal to +2 or X is equal to -2. However, that is not true. We cannot answer the question that way. What do we know about the number that the absolute value expression is equal to? It must be greater than or equal to 0. It must be positive. It's impossible for absolute value to be equal to a negative number. So there is no solution. There's nothing I can plug in for X that would make this a true statement. So in this case, this problem is no solution. All right, let's look at two more pretty basic examples that kind of have more going on inside the absolute value bars than just an X. Here we have another absolute value equation. It's an equation, not an expression, because it has an equals to. We refer to what is inside the absolute value bars, this 2x minus 1, that is an expression. So we have an absolute value equation. We're asked to solve and determine what values of X would make this true. So we have some steps, and I know I've said this before, but math is like a recipe, not just like cooking, but a recipe, as in baking, where you have to follow the steps exactly and you will always get the correct answer. So I've listed our steps out for us here. This is what we can do anytime we are asked to solve an absolute value equation. Step 1 is going to be isolate. So we're always going to isolate that absolute value expression first. That means I'll move the 5 over. Then we're going to use the absolute value properties, which we just talked about here on the first screen. So we'll use that absolute value property, and that allows us to separate the equation into two new equations that no longer have absolute value bars. So once we have those two new equations, generally in our situation, they'll be linear equations. We'll just need to solve each equation. And then remember, anytime you're solving ever, your solution should always check in the original equation. So let's go about solving this. The first thing we'll do is we will isolate. That means I'm going to add 5 to both sides of the equation. This leaves me with the absolute value of 2x minus 1 equals negative 3 plus 5 is positive 2. At this point, I have one absolute value expression equal to a positive number. So in this situation, now we're going to use that absolute value property and we will separate. I'm going to drop the bars. So I'm going to write this expression 2x minus 1. It is equal to either positive 2 or we'll have 2x minus 1 is equal to negative 2. So I'm applying that absolute value property we just learned about. And essentially it says the expression is equal to the positive or it's equal to the negative. Now I have two linear equations. I can solve each of these. So over here I'll add 1. That gives me 2x equals 3 and divide on both sides by 2. I have x equals 3 halves. Solving the other equation, again, I will do the same. I'll add 1. That is 2x equals negative 1 and divide by 2. I have x equals negative 1 half. I have two solutions that check. I have x equals positive 3 halves or negative 1 half. And of course, you guys should always plug your number in check. So if I took 3 halves, 2 times 3 halves is 3. 3 take away 1 is 2. Absolute value of 2 is 2. So we have a positive 2 here. Take away 5 is negative 3, and negative 3 equals negative 3. The same thing happens if you check negative 1 half. Negative 1 half, plug that in there, that gives you negative 1. Negative 1 minus 1 is negative 2. The absolute value of negative 2 is positive 2. Positive 2, take away 5 is negative 3. Again, it checks. Any problem ever, when you are asked to solve, your answer should always check in the original problem. So that's a good habit to get in the practice of, just plugging it back in to make sure you did not make a mistake, especially if you're going to be using that number to build or to move forward with for future calculation in the problem. Let's just do one more example. Again, we're going to solve an absolute value equation. So as per the steps we just discussed, we're going to isolate, separate, and then solve and check. First step is to isolate. I want these absolute value bars alone. First thing I'll do, since that 5 is added, I'm going to say minus 5 on both sides of the equation. That gives me negative absolute value of 4x minus 3 equals negative 3. Now, are my absolute value bars isolated with just an expression in between? And the answer is no. We have this negative in front. So that's like multiplying by a negative 1. And the inverse operation would be to divide by negative 1 on both sides of the equation. Now I have the absolute value of 4x minus 3 equals positive 3. And remember, my absolute value expression needs to be equal to a positive number. In the previous step, it was equal to a negative number, and that could have raised a red flag in your head. But now we have it equal to a positive number, so I will separate into two equations, dropping my bars. I have 4x minus 3 equal to positive 3, or I have 4x minus 3 equal to negative 3. So I'll add 3 to both sides. That gives me 4x equals 6, or rather x equals 6 over 4, 3 halves. On the other side, I will add 3 to both sides. That gives me 4x equals 0, and 0 divided by 4 is going to give me 0. My two solutions here are x equals 0 or x equals 3 halves. Again, checking. If I plug in 0, That is 0 minus 3, negative 3. Absolute value of negative 3 is positive 3. 5 minus 3 is 2. And you get the same when you check 3 halves. 4 times 3 halves, that's 12 over 2, or 6. 6 take away 3 is 3. Absolute value of 3 is 3, so 5 take away 3 is 2. Both of these answers check. And that's how you solve an absolute value equation. And that's really as hard as they're going to get in this class for homework. You just need to make sure that you understand that property and you know how to separate to eliminate those absolute value bars so that you can solve. As always, please feel free to reach out if you have any questions or concerns.